Hello world, it's Siraj, and I've built an app called SmartSneaks that lets anyone turn either a song or an image into a sneaker design, and it uses AI to do this. Let me show you how I did it. So check out this nice login page, by the way. Super cool, right? I know. All right, so let me log into this app and show you exactly how it works. First, I log into the app. And now this is a really bad UI, but like the functionality is there, okay? So first of all, I can choose to design my sneaker using a color, using this color picker. You know, that's the obvious way, color picker. Or the more interesting way, I can use an image. So, I click on this image and it's gonna take a snapshot of me. I could turn that image into a sneaker. Or the even more interesting way is I could select a song and I'll type in a song, like let's say Dead Boys by Sam Fender, one of my new favorite artists. And once I've done that, it's gonna load that. I know I should have showed it, like the song show up, but I haven't done that. What it's gonna do is it's gonna connect to the Spotify API, get that song, and then once I've done that, I can click next. And now it's converting that song into a sneaker design using a type of AI called a generative adversarial network. Okay, and once it's done, it's gonna show me a couple sneakers that look like they are the style of that song, and I'll select one of them. And I've selected one of these generated designs, and now I'll select my size, whatever that size is going to be, and then I'll click purchase. I'll type in my card number, I'll type in my CVV2, I'll type in my first and last name, I'll type in my expiration dates. This is on test mode, and then once it's done, okay, a user has made that purchase. In my database, I have stored that purchase, I have the exact design that they generated, and now either I or some partner who designs sneakers for a living can design those sneakers in real life and then send them to that customer. And then if I have a partner, they'll take a small cut of that transaction, but I would take the larger cut because I took this AI model, I paywalled it, and then I offered it to a user. Now this is a mock startup, and the reason I made this video is to show you how you can do this for retail, how you can build a retail business using freely available AI technology on the web. Okay, so that's the point of this video. I want to show you how I built this. And if we want to be really detailed about what exactly you're going to get from watching this video, thank you for being here. I appreciate your time. There are three core learning objectives from this video. The first one is how to build your own deep learning API for your mobile app. And by that, I mean, you don't always want to put deep learning models on a mobile app because these things are big, right? They take up a lot of memory. They take up a lot of processing power sometimes. And ideally, when you have your simple, clean, light client mobile app, you want to just call it from the cloud. And in the cloud is where you store your deep learning or any kind of machine learning model that you've trained. And it's like, oh, you want to turn this image or this song into a shoe? Okay, let me generate that. Okay, I've got the generated shoe. Let me send it back to you, to your mobile app, right? So it's a very thin, light client. That means it's fast. That means it takes low power, which is great for mobile applications. And this is just a really good practice in general for you to know, okay? Any kind of business you want to make with AI technology. The second one is how to generate images with a generative adversarial network. Now, look, I know that there have been a million blog posts on this by now, how to do this. I know I have made a lot of videos on this, but I've never used this interactive generative adversarial network to demonstrate how it works in real time. So that's the novelty on that end. I'm going to show you how it works using visualizations. And lastly, how to calculate image similarity with OpenCV. So the way that works is this generative adversarial network that that I've trained, it's been trained on a bunch of sneaker images, right? But how do you know to convert a song into one of those sneaker images? Well, let me just explain to you very quickly how it works, pseudocode style. First of all, we take the song, we convert the song into an image using what's called a conditional generative adversarial network. A lot of terminology, I'm going to explain it all, don't worry. We turn the song into an image, and then we got a bunch of generated shoe images, and then what we do is we compare the image of that song to all of the generated shoes, and we try to we compare that image, the pixels in that image, the RGB values with the RGB pixel values in all the other shoes, and it iterates through all of them. And when it finds the one that is some threshold, maybe the top 10, the top 20, it's going to return the top 10 or top 20 that are the most similar to the image of that song. Now, this is very important technology. You might be thinking, well, I don't care about sneakers, but you do care about making some money with AI technology, and this is a great example. You're going to learn a lot in this video, so stick around. I can't wait to teach you this. Here we go. All right. By the way, if you're new, welcome to the channel. Hit the red subscribe button, and whether you're new or you're old, hit the bell icon, which I've never said on this channel before, but this is necessary. Apparently, there's a difference between having a subscribe button and a bell icon, and so if you want to get notified when I release these new videos for free, definitely hit the bell icon so you get that notification, because the subscribe button alone isn't going to give you that notification. All right, here we go. So first of all, if you're watching this and you've never coded before, that's great. Welcome to this community. I love you. Welcome. Okay. I embrace you. We all embrace you. This is a learning community. We are all supportive of each other. Go ahead and watch my Learn Machine Learning in 3 months video to learn it super fast. It doesn't matter if you went to whatever university, if you didn't go to college, if you didn't go to high school, I don't care where you live. Watch that video, complete that 3-month curriculum in your spare time, and you will learn it super fast, and then come back to this video. Okay. And even if you haven't coded before, watch it anyway. This is going to be super interesting, okay? This is some cutting edge 2019 technology that can be commercialized today, and you can actually make some money. You can get hired, you can get consulting clients using this technology, okay? This is very valuable knowledge, all right? So how did I build this? Well, first of all, I use a technology called Flutter. If you've been watching my startup series, you know that I've been using Flutter quite a lot, because you can make an iOS app and an Android app with one code base. The language is called Dart. Don't worry if you never coded Dart before. I didn't either. You can learn Dart in like a day. It's super beautiful and easy. It's amazing. It's beautiful. I'm a new Flutter fan, so I built it with Flutter. I built the mobile app with Flutter. In terms of payments, unfortunately, we do not live in a world where a single payment processor can access the entire world all at once. That's not volatile. I know you're gonna say Bitcoin, but that's not volatile. And so what we have to do is we've got to use Stripe for most of the world. We've got to use Razorpay for India, and then we use PayPal for a bunch of other countries that are not supported by either Stripe or Razorpay. Okay, so then in terms of cloud storage, how do we store these user accounts? Firebase is my go-to. It's super easy to use. Cloud storage, it's got all these features. Firebase. The second is the Spotify API. So when a user selects a song that they want to convert into a shoe, what happens is you type in the song, it then queries Spotify, which is a music playing service. It gets back that song, and then we can turn that into an image. In terms of the actual AI part, we're going to use TensorFlow 2.0, which is the most popular machine learning and deep learning library out there. In terms of performing that image matching that I was talking about, we're going to use the OpenCV library for Python, which is a super not old, but it's been around for like a decade. It's super useful. It's amazing. I didn't really give it too much credit before because I was so obsessed with convolutional neural networks, with deep learning, and how, all these state-of-the-art performances are, being broken by deep learning models, and that's amazing. But OpenCV, it's got its place. All right, let's give some love to OpenCV. It's pretty amazing. And lastly, how are we going to build this API, right? We've got this mobile app, but we also have this web app. And so the way we're going to build the web app is to use a Python framework for building web apps called Flask. And why Flask? Because TensorFlow and OpenCV are in Python, or at least the best versions of them that are the least likely to break are in Python. And so we want the whole stack to be in Python to make things easier for us. We care about simplicity, okay? So that's why we're going to build that in Flask. We're going to build our mobile app in Flutter, and we're going to have them talk to each other. Now, I also want to say one more note. Yes, Stripe and PayPal and Razorpay can reach most of the world, but it's not going to reach China, which 1/3 of the world's population lives in. In fact, so many things are blocked in China. Whatever web host you use, it's probably blocked in China. Whatever payment processor you use, it's probably blocked in China. A lot of APIs you use, both the Android and the Apple App Store, nothing's available in China. So my suggestion to you when you build something for the rest of the world, which you should, because if you don't don't, someone else will, right? Everything you build these days should be for everybody in mind, not just one niche market, because if you don't, someone else will. And so it's not just based on good intent, it's a business decision. If you want to build something for China as well, and you should partner with somebody in China to build the Chinese version of whatever you're making, and then give them a cut. And you know, I've done this for my content. You know, I have several Chinese partners who are pushing my content, translating it to China for free. You know, there's not really a business relationship, but I'm just giving it to them. They might be profiting off of it. That's fine. All I really care about on this end is just getting the word out on how amazing this technology is and all the great things you can do with it. So just a note on that end. So in this tutorial, we're going to go through 10 steps. The first one is to install Flutter and Android Studio. The second one is to download and run a base application. And what do I mean by a base application? A base application is one that we can build on top of that saves us some time, right? We don't want to build everything from scratch. We want to stand on the shoulders of giants. The third step is to design that selection page that I showed you. And that's just really a practice to show you what widget trees look like. The fourth is to add payments. Then we're going to generate those images in Python. We're going to create a Flask app to wrap those that AI model around. Then we're going to create a request from the mobile app to the Flask app to get that data. And we're going to compare images with OpenCV with whatever is sent, right? So like, okay, here's the shoe that was selected, or here's the song now, and it's converted into an image. Now compare it to all the other images. And then we're going to complete that whole mobile purchasing funnel on the mobile app. And then lastly, we're going to talk about ways to improve the app. So if you're ready, here we go. Okay, so the first thing I want to do is I want to download Android Studio, and whatever system you use, Windows, Mac, Linux, Android Studio is going to work for you. This is the best developer environment to build Flutter apps in. You know, people who use Atom, I love you too. Sublime users like myself, I still have the unregistered version of Sublime. At this point, it's just become a meme, so I'm just going to leave it like that. But Android Studio is epic. And the reason it's really epic for Flutter in particular is because you can download dependencies from inside of the IDE, which is super cool. It's super useful. Now, so that's the first step, download and run Android Studio. So you click that. You know, I already have it, but I might as well just show you what it's like. Download for Mac, boom, you run the file, and then you just, that's it, okay? So that's Android Studio. And then once you have Android Studio, you're gonna say, okay, Android Studio, I already have one version of the app, but Android Studio, new project. Okay, what is that project going to be? We're going to build off of a base project, so it's not going to be a totally new project, all right? So that's Android Studio, and then we're going to install Flutter. Flutter is right here. So whatever your system is, you go to flutter.dev/docs. I'm going to select Mac. Whatever you have, you do that. And basically, you're going to use what's called the command line terminal. This is terminal. Say, love you, terminal. Love you, terminal. And you make it really big so people can see everything. And then you type in these commands one by one, right? So first you download it, it's a package, you unzip it, so you're typing in one by one, right? All these things, you export the path, and then you run the Flutter command and whatever. And so there you have Flutter. And actually, there's a way to install Flutter from inside of Android Studio as well. So if you just don't want to deal with terminal at all, you can do that from inside of Android Studio right here. See, start Android Studio, plugins right here, these 5 steps. So just check that out, by the way, all right? So that's that, okay, that's how we install our dependencies. Now, where do we begin with this app, right? So, you know, I really was not happy with my design skills. Like, I'm not necessarily a good designer. I'm not a good designer. I don't really focus on good design. I really focus on really complicated new technologies. That's where my interest lies, and I'll admit that. I know my flaws. So I wanted to make up for that by starting off with a base application that was beautifully designed. And basically, I went to GitHub, this amazing repository of value that anyone can build on top of and make money from. And I found this login page built with Flutter, heart sign. And here's the login page right here. Look at this. You got the login, you got the sign up, it's in one page, you got this nice little scroll bar. So I said, okay, I'm gonna download this. Great. Why not? Let's run it. So we're gonna do this together. I'm gonna do this from scratch. So I downloaded it. I'm gonna open it right here. It's gonna open up Flutter. Okay, not Flutter, it's gonna open up the app. Here's the app, it's located right here. And okay, so there's the app. It's called the Gorgeous Login Master 1. Great. So now I'm going to go to Android Studio, not the existing project I've had. I'm going to open a new project, and I'm going to say open. Hold on. Nope. Let me just close this out. I'm going to say open import project. And that project is called the Gorgeous Login Master. Okay, so here's my new project. All right, it says packages have not been run. Get my dependencies. So this is what's great about Android Studio is you can get your dependencies from within the app. Now, I've got that aspect. Now I'm going to run the app. It's going to initialize everything. It's going to say, okay, we want to install everything. I feel you. We're going to compile everything one by one. It's saying, I love you. I'm anthropomorphizing this code. There it is. Okay, so there it is. I have just downloaded it. Did you see how easy that was, by the way? This is why I love Flutter. I downloaded it. I opened it in Android Studio. I hit compile, and there's the app. Look at this. I could white label this. I could say whatever I want. This is, whatever. It's my new app. So that's great. That's the great thing about open source. It's all open for profit. Okay, a lot of the greatest products on the planet, all the greatest products on the planet have been built on top of open source technology. So don't feel bad. Okay, that's why they put it out there for people to use. Don't feel bad about taking this idea that this is open source, right? Go make some money, build some wealth, and then focus on your life and getting independent. I'm trying to get you to be independent over here. Financial freedom, okay? You don't need anybody, okay? That's the benefit of this technology. Automate intellect. We've already automated physical strength. Now we're gonna automate intellectual strength. And then we can focus on health and wellness and other things. So let's not get too philosophical. That's the app. Now, we've done that part. Let's keep going here. Now that we've run that base application, we want to add the login and sign up code for Firebase. So notice that this app does indeed have login sign up functionality, but it's not connecting it to anything. So let's look at what's inside of here. So the main.dart file is what's actually running this application. And if we go into utils, we can see the other Dart file. So by the way, in Flutter, under the lib folder, that's where all the Dart code is. And what happens is the Dart code compiles down into Android and iOS code. So you don't have to actually look at the Android and iOS code. But if you wanted to, you could. You could just say, well, what's happening in Android over here? What's in the app? What's in there? What's in Java? What's it? All the way into the, boom, there's some Java. But we don't care about Java. We don't like Java. We don't like Java. We like Dart. Whatever you like is fine. I don't like Java. I like Dart a lot. So let me close out of that, go back into lib, utils UI. There's my login page right here. So this is the code. Let me make this really big for you. It's got to be bigger. So check out this code. So this is a lot of code over here, I'm noticing, okay? So what's happening here is it's building that login page. You don't have to understand everything here. Just know that this widget code, it's building everything that we see. It's building that scroll view where we scroll across for sign up or login. It's building the color scheme. It's got that image, that login logo, which is those two people high-fiving each other right here. It's building that. Let me put that over here. And then it just goes down like sequentially, like what's next? Okay, now you've got to put that place for the email page, the sign-in page, all of that stuff, the sign up and the email page, right? So what we want to do is we want to add some code to this that enables this whenever a user signs up, we want to save that somewhere. We're not just going to save that on the phone. We're going to save that in the cloud in a database. And so that's where Firebase comes in, where we say Firebase Dart Flutter. Both of these are Google products, so they integrate pretty easily. So we've done the first part. We've set up our environment. Then we're going to create a Firebase project. Okay, so we'll go here to our Firebase console. Then we're going to say, let me create a new project. It's going to be called SmartSneaks. And then, that's SmartSneaks. I accept everything, take all my data, take all my data, creating the project. In the meantime, let's go back here. So that's creating that database in the cloud. And we have this Flutter app on our device, and we want to talk to that database, right? So whenever a user signs up, we want to send that login information, that sign up information to the Flutter database, and then it's going to store that. And so every time a user logs in, it's like, let me check those credentials. Oh, there you are, user, boom. And then they get the authentication code and all the other all the other data that's associated with that user, like whatever sneakers they bought in the past. We'll store all of that as a bunch of rows in the Firebase database. So we're not trying to configure anything like that. So here's what we do. We will add that right here as a dependency. You guys don't even, hold up. Flutter, even Google's own documentation's too much. Like Flutter Pub. What is it called? It's called the Flutter Pub. This is where all the packages are indexed that we can download. So I'll say Firebase. Which one has more? Okay, here, this one has 100. It's ranked 100. I love 100 things. Example, installing. Okay, that's all I got to do. Okay. Firebase storage. So what happens now is when we add this dependency, we say, okay, so to add Firebase functionality, all we have to do is we have to go to pubspec.yaml, under dependencies, add this code, Firebase storage. So let me see where that is. Pub, there it is. Here's dependencies. Okay, copy, paste. Okay, notice that I changed something. So now I have to download it. Boom, Firebase is integrated. Okay, so now I run Flutter Pub get. Now in my Dart code, I can add this import, and that's going to say, okay, now you can call a bunch of Flutter commands, and I'll say, okay, there's my Dart code, Firebase storage.dart, and now I can write that Firebase logic in there. To see that, I'll go to the repository on GitHub, and I want a nice little code snippet for login sign up. That's what I want. So show me that login sign up, sign in. That works too. Yep. Firebase sign up. Sometimes Medium just works. Thank you, David Chia. Get out of here. Okay. Yep. Firebase auth. Okay, so right here is that code right there. So I'm just gonna go ahead and paste that in right here. Boom. What do you mean? Oh, it's another package, Firebase auth? Okay, how about Firebase auth? How about that? Catch me on Firebase, how about that? Is that not a thing? Hold on. That's a whole nother package, isn't it? Firebase auth, Flutter Pub. Of course. That's what it is right there. Okay. Yes, great. See, no errors. There's my code right here. So now I've got a bunch of functions that I can use for login and sign up. So I've got those strings already. That base code has already got me both the username, the email, the password, and it's got that built-in regex functionality where it's checking if everything is valid. So now I can just call one of these functions from within the app right here, sign up, sign in, using the parameters right here, and there's my Firebase access. Now, obviously, I've got to also connect it to that Firebase account that I made called SmartSneaks. Right here, I'll use one of my many accounts right here, one of my many projects right here. And in my database, it's going to show up as a new user. Let me make sure that it's connected. Let me go back to this, Flutter Pub get, yep, examples. And then I've got to add this either to my info.plist file for iOS or for Android. I've got to download Google services.json and then download that there. So here's the instructions right here on how to do it for both Android and iOS. So the great thing about Flutter is that we can code in one language. Yes, amazing, thank you. But why are there bugs in here? Oh my God, it's summer. So yes, we can code the language in Dart. We don't have to worry about Android or iOS, but sometimes we have to dive in, do a little bit of authentication work sometimes. So this would be one of those cases. So we do that. Okay, we do that, and then let's keep going here. We've got a lot to talk about. Now, once we've integrated Firebase, we've got login and sign up functionality, then we want to design that selection page by building our own set of Flutter widget trees. And to recap very briefly, in Flutter, everything is considered a widget. A widget is a software construct. It is a type of object. We can consider it an object. And First of all, we have our top level widget, which is the entire app. And then from that app, there's a tree of widgets, and each of these widgets depend on another set of widgets. So let's say we have another widget called home, and home is the home page of our app. Inside of that home page, we create another widget called a scaffold. And inside of a scaffold, we can create a bunch of other widgets one by one by one. So we'll add an app bar at the top, that's a widget. And then we'll add a title page, and then we'll add a row, and inside of that row, we'll add some text. So there's an embedded widget in there. And then under that row, we'll add a checkbox, right? So there's a tree of widgets that we're building, a widget tree. And that's the idea behind Flutter. So what we're gonna have to do is build a widget tree for the selection page of what type of data do you wanna convert into a sneaker. And one more thing before we do this, there are two types of widget. There's the stateless widget and the stateful widget. And the difference, you're gonna see this a lot in Flutter, the difference is that for a stateless widget, you cannot change that widget once it's been initialized and built. But for a stateful widget, you can change the state of that over time. So it can be dynamically recreated throughout the app. And there are different use cases for each of these constructs, but we're gonna focus on, we're gonna focus on both actually. So now we wanna build that selection page where we select a song, we can select an image picker, we can select a color list, things like that. So let's go ahead and do that. So you might be thinking like, how do I do that? So I'm just gonna show you exactly how I would do this. So first of all, we'll go back to main.dart and we'll say how to connect. I think this is important to show you like how to like think about solving these problems. Basically, Google them and then find the answer and then implement them. Like it's okay to Google things. It's okay to Stack Overflow, copy paste snippets, whatever works. Fastest method to prototype, rapid experimentation. We're trying to build something very fast here. So how to connect Flutter page to another. And so then it's going to be like, here's how, navigate to a new screen and back. So it's basically you create two routes. You got your first route and you got your second route. And what happens is, I want the complete example here. Okay, whenever one thing is pressed, we will say push and go to the second route. So on sign in button press right here, we're going to do all this. So here's our logic for on sign in button press. So what we want to do is on sign in button press, we want to push this code to the next widget, which is the next page. We can think of it as the next page. And we're going to just type that in right here. But then it's going to say, well, there is no second route. What are you talking about? What is second route? So now we're going to build that second route. Okay, and this is our next page. And so here's kind of what it looks like. Here's a little animation. Second screen, first screen, second screen, first screen. And that's how that works. So we're gonna go down here and we're gonna add that second route. And once we add that second route, it knows, okay, you wanna go there whenever you hit sign up. And we're like, okay, of course we do. So now in that second route, we want to design some kind of UI to add in the options of taking a music and turning that into a sneaker, taking an image, turning that into a sneaker, taking a color picker, turning that into a sneaker. So what we do is we basically just go and we check the Flutter packages. So I'll just say check, color picker package on Flutter. Oh, here's one. So I'll just add that to this. And it even shows you the example. As you saw in my demo, right? I showed this. This is a totally fully built little widget screen. All the components are there. We just basically install this dependency and then we paste in this code and that's it. That's super easy, right? Even if you've never done Dart before, it's super easy. So let me just do this really quickly. You go into PubSpec, you type in this Flutter Picker package, you install it, it installs in 1.1 seconds. That's it. Run get, and now we erase that dialog right here. So that's what we're gonna do for that dialog. And this is basically a show dialog. So where do we want to do this? We want to do this inside of that raise button on pressed. So let's say whenever this button is pressed, we're going to have one single button. And for now, we'll say, okay, so whenever that button is pressed, we will run that. And so it's giving me an error. And that's because I need to import that at the top. So come on, but show me the import though, guys. Where's my import at? There we go. Thank you. I appreciate that. Awesome. Amazing. Yes. Yep. Material as well. Do I have material? Okay. Okay. So that was for the color picker, and we would basically do the same thing for Spotify. We would do the same thing for an image gallery. We'd just search image, Dart, Flutter, package, and there's like a million of these image packages. And then we just install it, and look at this little snippet over here. Take whatever image you need, image picker. Okay, that's your image picker. If we want Spotify, we search Spotify. Okay, so just like that, you know, one by one, we just go through add. And we do the same for payments as well, right? So whether it's Stripe, whether it's, there's Stripe, whether it's Razor Pay, whether it's PayPal. Is the PayPal package not there? Are you joking me? The PayPal, oh my God, what? Wait, this is crazy. PayPal Flutter? I really thought PayPal was gonna be there. Yo, PayPal, what's good? All right, forget PayPal then. I mean, we could just build this like from scratch using the native API, but you know, we don't have time for that, okay? We're trying to build something, we're trying to change lives over here. So now let me get to the generating images part with adversarial networks. First of all, I have talked about generative adversarial networks like in like 4 or 5 or 6 to 7 different videos now. I don't want to repeat the same thing over and over again because I respect your time. So go ahead and watch this video. I think it's very useful, generating Pokemon with a GAN. And in fact, I think it's so useful that I'm going to be reusing that code right now to show you the raw NumPy version of how a generative adversarial network works in a second. But first, I want to show you the visualization of one. So check this out right here. So here we go. Check out this beautiful thing. I'm going to have this run. So now it's running. So here's what's happening. The way this works is we have 2 neural networks, and one of them is called the generator, and one of them is called the discriminator. And then we have some data set. Let's say it's cat faces for now, okay? We're gonna take these cat faces, and we're gonna generate new types of cat faces that look very similar to what existed, but they're unique. And we can do the same thing for sneakers. We can generate new sneakers. We can generate new types of room environments for videos. This is a very extremely popular model. In fact, it is so popular, okay? It is so popular, the generative adversarial network, that let me just show you how many variations of these exist. And this has only been around for like 4 or 5 years now. Here are all the different types of GANs out there. The align GAN, the APE GAN, we're still in the A section here. I can go on all day. Here's cat GAN, Psi GAN, Sin GAN. I feel like one of these, it's probably gonna be like a bad word. So I'm like trying to be dialogue GAN, disco GAN, DNA GAN. Oh, DNA, wait, what? DNA GAN. Let's take a little second to look at that, DNA GAN. Ooh, I've got a nice little paper to read later. Oh, it has nothing to do with DNA. Get out of here using DNA in your name. You guys keep going. Dropout GAN, that's like me, dropout status. And there's a lot of these GANs out there, okay? There's a lot, that's my point here. Let's get really serious now. I don't know, I'm feeling kind of fun today. I'm feeling kind of fun. I'm happy, I'm fulfilled, I'm independent. I wanna get you there as well. So what's happening here? So one network is generating new images, one is detecting if that image was real or fake, and they both get better over time. So in mathematical terms, what's happening is the generator is first of all, it's detecting the distribution of the data. So there's a distribution of the data. So there's so much to explain here, but I'm excited for this. Here we go. When we have some data, okay, let's say we have an image of a cat. This cat has a lot of features, okay? Now let's try to plot what this cat's features are as a point in n-dimensional space. So how many dimensions are there gonna be? First of all, one of those features / dimensions is going to be how pointy that cat's ears are on a spectrum. So that's one dimension. Let's say, 32 centimeters, or I don't know. Another dimension / feature is going to be how brown the cat is. That's 2 dimensions. Okay, 1 and 2, pointiness, brownness. A third dimension is going to be how fat the cat is. And that's a third dimension, okay, fatness. A fourth dimension is going to be how many stripes the cat has. Now we can't even visualize that because we live in a three-dimensional space. But data doesn't care. Data is highly, highly dimensional. It's got millions of dimensions, right? But we want to be able to visualize that. So we can compress that data into a two-dimensional space so we can view it with our puny human minds. There's a lot of great things about being human. I don't mean to say that. So when we do that, we get this distribution of data, which is what we see right here, this green image. It's all the points of all the data points in our data set. So what we want to do is we want to try to match that distribution of data with our generator. And so what the generator is doing is it's built this manifold. And this manifold is this construct, this mathematical construct that is the representation, the 3D representation of a bunch of points in n-dimensional space. Let's say 3-dimensional in this case. And so what's happening is, first of all, by giving it the generator some noise, that's just random data points. So randomness is how it starts off. By giving it some noise, first of all, it's going to generate something totally random. And then the real data set's going to say, here's a real cat picture. Both are going to be fed to the discriminator. And then it's going to be able to predict what's real and what's fake. And then after it's made the prediction by performing a series of matrix operations, then we're going to apply the label to it because we know what's real and we know what's fake. It's going to compute the error, how real or how off it was with its predictions. We'll take that error value and then we'll compute, stochastic gradient descent that I've talked about a million times before to then update the weight values. So that's calculus. So notice what we're doing here. We're performing linear algebra to perform the matrix operations to both generate and discriminate. We're performing calculus to update both of these networks so that they get better over time, so that both of those distributions are more merged with each other. They're more aligned. And so that's what you're seeing right here. The green is the true data distribution. The purple is the generated data distribution. The lines that you're seeing are the gradients. And the gradients tell us which direction in n-dimensional space to move our distribution so that it's more aligned with whatever we're trying to optimize. In this case, we're trying to optimize how similar that distribution is, the generated one, to the actual distribution. And once we do that using these gradient values, then we'll get a generator that's so good that the discriminator won't even be able to tell what's real and what's fake. And once we do that, then we can take that generator, we can say to the discriminator, bye, we don't care about you anymore, forget you, and now we have the generator, and now we can say, hey generator, generate a new cat image, and it's going to make something so beautiful, it's going to look real. You're going to say, what? This looks so real. That's what's happening here, okay? So I hope that was useful. Okay, so once we do that during the training process, by the way, this is a great little write-up. So definitely check out this write-up if you want to learn more about this. I definitely had a lot of fun reading this. And shout out to Minsuk and Nikhil and everybody, Polo, everybody on that team, okay? So now, I wanted to say that there's a lot of applications for GANs out there. Like this little demo is something that Nvidia made, which is super cool. You can actually run this in the browser as well. I was actually just on the phone with them and they were telling me about this. Where is that little in-painting thing? Nvidia, it's called like GALGAN. Oh yeah, check this out. Check this out. You're gonna like this. Don't go anywhere. This is gonna be cool. So check this out. This is using generative adversarial networks to help someone draw in real time. So let's say I want to draw like a little sunset here. So I'm going to say, okay, the sunset's going to be like this. It's going to be a giant sunset. The rays are going to be all over the water. And once I'm done, then I'm going to say, okay, go. And it's going to generate something like that. But so check that out, by the way. So this is what it can do. Like you can really create some beautiful rendering, beautiful images with this. And that's what really this technology is. Generative technology is a tool for artists, for engineers, for creators to visualize your ideas in a way that you could not before without needing that domain knowledge. Because guess what? That domain knowledge is not in your head, it's in a machine. So that's the beauty of it. You don't need 10,000 hours to be able to draw this. You can just do it. Now, the other great thing about GANs is besides just generating new types of images, you can synthesize, you can convert one type of image, one type of data into another. So in this case, you can say, this small blue bird has a short pointy beak and brown on its wings. And from that text, you can generate an image, which is wonderful. That's amazing. You can turn zebras into horses. You can even generate new types of drugs for saving people's lives. And that is going to be something huge in the next 5 years. Mark my words. So that's that. Now, there's one more part I want to talk about. So check this out. I found this paper called, what was it called? Towards Audio to Scene Image Synthesis Using Generative Adversarial Networks. They took a sound file and they were able to generate an image that was that sound. So this is baseball.
Do this. Whoa! Nice! Can't go.
From that, they generated an image. And the same for a dam, like, water's rushing down. And they generated a dam from that. And so how did they do this? It's got that data. Remember, it's just mapping the existing audio to the images. It's finding the mapping, and then it can generate more. It's that. So the way we can then select features of what exactly we want it to look like is by using what's called a conditional GAN. So we can condition the data that's generated on some set of features. So what conditioning means in this case is we are adding a little extra. So not only are we giving it some image like a cat, we're also giving it what each of those features are. Like, hey, we're going to checkbox, 0 or 1, that this cat has black hair, or that it's blonde, or that, it's got fat, fat neck or something. These are all features that we're conditioning it on. And so what's happening is that in latent space, that n-dimensional space that exists as a compression space that is, outside of the bounds of what we can visually see, what's happening then is it's learning those features and it's interpolating that into what exists inside of that latent space. And so then when you say, I want a cat, I want you to generate a cat with, X type of hair and this type of features, it's going to say, oh, okay, this type, I know what that looks like already because I've learned that compressed representation. Here's what it looks like. So it's learning a distribution around data. Now, in terms of image generation, this is a deep convolutional GAN. I found it on GitHub. It's called Sneaker Generator by Mika5. Good job, Mika. Love that. He's got a little demo here on the web, but unfortunately, it doesn't work. You should fix that. People are going to be going to this now. So DC GAN, it generates sneakers. He ported it to TensorFlow.js. And that's it. This thing runs... it's got TensorFlow.js too, but it's got Python as well. And so we're going to use that code to generate the sneakers. Same basic idea of generating an image from a data set. Okay, so now we're going to create that Flask app so that we can put that code in there. So let's do this together. Flask, how do we do this? Flask app example. Quick start. Open terminal. For web apps, we gotta have terminal handy. I mean, you know what it is. I already created a folder here called SmartSneaks. And so I'll make the code. I'll make the code. Sublime, open Sublime up. Where's Sublime at? Put that code in there. I'll call it hello.py. Okay, fine, I'll just do it in Nano then. Fine. Yep, there it is. Okay, then I hit export. Flask run. Running at 127.001. This was running on my local machine. Hello world. Okay, great. So let me open that up. Okay, so that's my Flask app, and I can change. I can say hello world, whatever it is, and then I just Flask run. Okay, so that's that. I've got my code here, and now I want to build an API with this. So how do I do that? How do I build an API out of this? So I'm going to go back here. I'm going to go to Flask API example. There we go. Thanks, Miguel Greenberg. Look at this. Beautiful. Everyone's sharing. The world is great. We've got so many great people who are sharing things on the internet. So what I want from Miguel is I want to know how to do a post request from Flask. So here's the code. I'm going to explain in a second. There's the code. Okay, so that's the code. Now let me talk about, before I talk about what I did, let me just make sure that this works. And now I'm going to do a request here. Okay, so when I hit curl, it returns that JSON file that I requested. So let me show you what's happening here. So what I did was I created a Flask app. Inside of the Flask app, I created a single route. Inside of that route, I said, okay, so basically each of these routes is a different website address. So, you know, wherever I upload this Flask app to, right now it's on my machine, so it's going to be 127.0.0.1, which is my own address. But eventually when I upload, it's going to be like, you know, sirajapp.com, whatever it is, /to-do/API/ whatever. I can name it anything I want. So right now, it's just this. And I said this is a post method. So whenever some data is sent to it, it's going to return something back. So right now, this logic is to say, okay, first of all, error check if this is a proper request. And if it is, take this task right here that I've, it's an array that I've constructed, and return that to whoever has requested this task right here. And I have several of these tasks right here, okay? So what happened is from terminal, I made that request directly, but usually a user, whenever they visit your website or app or mobile app, you know, as an example, when they request some data, it's not going to be in like a URL. You're not going to see that, but it's happening on the back end. So what I did here is to show you, you can request your own app locally. You can send some data to it, post some data to it, and it'll return some data back. So in our case, what we're going to do is from our Flutter app, we're going to post some data to that mobile app, to that web app. Now, let me ask you a question. What is the data that we're going to send to our web app? I hope you said it's going to be a song or an image, because it is. We're going to send that song or image as a JSON file to the web app. The web app is then going to perform inference using an AI model to convert, first of all, that song into an image using the conditional GAN. And then it's going to convert that image into a sneaker design using the DC GAN. And then it's going to have a bunch of sneakers. Then we're going to perform OpenCV to then compare the image that was sent to all the sneakers, find the best ones or the most similar, and return them as a request. And then in Flutter, we're going to have all those images, and then we can display them to the user to pick the best one. They're going to choose the best one in the best size. They're going to pay. We're going to restore all of that in our database in Firebase, and then we're going to check for all of our sales, and then we're going to print out the shoes and send them to those users and make some money. Okay, you see the flow here? So now we're going to add in that beautiful code for the sneaker generator. So for the sneaker generator, what we can do is we'll say, since this thing has already been trained, you'll need Keras installed. Great. So I'll say inside of Flask, import Keras, or import TensorFlow, basically. And then, because Keras is now a part of TensorFlow 2.0. And then we're going to say predict.py. So let me just download this puppy right here. Download Python, predict.py. Here's a beautiful example of a generative adversarial network. We have our generator, a bunch of matrix operations, one by one by one by one. And then we have the same for our discriminator, which is not here, but I guess that's because it's for prediction. Remember, we throw away the discriminator, and now we predict with that. So what we can say is from this predict.py file, say from sneaker generator, import predict. What is the function we want to import? Yeah, predict. And then we're going to run predict. So we're going to have to modify predict, so it's going to take in that parameter. It's got the weight file right there as well. We're going to add that code to our Sublime file. It's going to generate some images. Great. Okay. So what I can say is, let me just add to this very roughly right here. I'll say predict. This is going to be like images. These are the generated images, generated shoe images. And let me take the request.json, whatever has been sent, and this is going to be my song. Let's just say it's a song for now. This is my request.json. It's going to be a song that I receive. And now I want to convert that song to an image using the conditional GAN. And then I'm going to compare images via OpenCV. And so I'm going to convert the song to an image. And so I've got the song, and I want to convert it to an image. And I'm going to go back to this code right here. There we go. Yes. Okay, so we're going to download this code right here, audio to image generation. There's several examples on the web. Ooh, that's interesting. Audio to guitarist. Oh, that's so cool. From a song, it converts that into an image of a person playing a guitar. That's so cool. I can make a whole video on that, but so much to make a video on. Great. So we have that. We downloaded it. We're going to import it into our Sublime file. Import, what's the name of that file? Audio, not this one, the other one. Attention GAN. What's the name of it though? Import models. And then I'll say, here's a parameter, the song. It's going to return an image. This is pseudocode. I'm going to clean this up, but I need to show you the idea here. There's a lot more work that needs to be done here, but I want to show you how I'm thinking about this. That's what matters. Image, song, image. So first I get the song, then I convert it into an image, and then I generate a bunch of shoe images. So image 1 versus generated images. Base image. Now via OpenCV. So how am I going to compare this via OpenCV? So OpenCV has this function called compare hist. Basically, you can turn any image into what's called a histogram. And a histogram is basically mapping an image's red, green, and blue pixel values across the image like this. So you can see like what parts of the image are red and green and blue, and it comes out to this. And we can take these values, these disparate values, and we can concatenate them into a single scalar, like a scalar value. And that represents the image's essence. And then we can compare that essence, like the color essence, to other color essences of images and see which ones are the most similar. And so that's what we're going to do. We're going to find the generated images that are the most similar to the ones that we've created from a song using compare hist. So I'll say, okay, compare hist OpenCV example. Not in C. I mean, C's cool, but like not in C. Ahaha. Thank you. So that's our base image. Then we have our histogram that we derive from it. And then we have our generated image is, let's just start with the first. And yep, we derive that from that. And then we compare them using this. And that's our comparison. And we're going to iterate through each of them. So we'll start off with a single one. So we compare them both. And let's just say like if A is over a certain threshold, let's just say if it's not equal to null, like if that comparison worked, good, return something, return the generated images, the first one that we just compared. Now to add on to this, we'll add on a for loop to then compare all those generated values, all those comparisons we made with the histogram, and find the value that is the highest, or perhaps the highest 10, and then we'll return that as a JSON file. And so that's our API request. So that's that. That's for the static image. Let's keep going here. Complete the mobile purchasing funnel. So I've added that in, and let me see what else I can do here. So I've got the rest of the code here for you. The whole design funnel works. There are little pieces that I need to add in to make it better. Obviously I made this in like 3 days, so it's not like a fully feature ready app ready for millions and millions of users. But it is something to give you some inspiration and education on how this would work, to show you that AI can be used in retail, and in fact, it can be used in every industry for you to start building some wealth with. So check this out. What else? Last thing I want to say is there are ways to improve this app. Better integrated color design, A/B testing. I haven't even talked about testing. I need to make a video on testing. Cleaner object-oriented code, and continuous training in the cloud, which I will make a single dedicated video towards because I keep mentioning it at the end of all of these videos. So if you like this video, smash the like button, comment, let me know what you think. I love you guys. I do this for you. And for now, I've got to go make some more videos and educate more people. So thanks for watching.